to Brad Adams and Levi Zelaski's Power Systems and Electronics Project presentation. Our topic of choice was wireless power transmission using Class E power amplifier with solar output or solar input. Let me see. Levi, can you approve
Yep.
that?
Sorry, there you go.
Thank you. So the agenda for us is laid out as such. This is to take you through the lifetime of our project and aid for you in the understanding of our process. Wireless power transmission is the transmission of power without having utilized wires, cables, or conductors of any type to get power to the load. Wireless energy has been around for some time now, dating all the way back to when Nikola Tesla created the Tesla coil. Nowadays, wireless power is becoming very popular with the addition of wireless charging in modern cell phones. For this project, we'll be using a renewable energy source to power our wireless power transmission device. A solar panel input will be used to achieve this renewable energy source. A solar panel produces a 12 volt DC output. A high step DC to DC converter will be utilized to get output power higher. Once the source is at 60 volts, that will then be in the input for the Class E amplifier. The reason a Class E amplifier is being used is because it can achieve close to 100% efficiency. The output of the Class E amplifier then sends the AC power to the receiver, which would receive the end result of 110 volts at almost 24 watts. The main project objectives. These are to create a solar-powered output large enough to operate a 24-watt device at 110 volts using a solar panel as power source. Create a close to 100% efficient wireless transmission device using a Class E power amplifier, and accurately design and create the system within Multisim for proof of concept. Little introduction and background to this. Wireless power has been around for a long time. Nikola Tesla originally created wireless power with the invention of the Tesla coil. For perspective, this invention was created over 100 years ago and was able to transfer power over a short distance without using any type of conductors or connecting wires. This invention prominently displayed what is often considered to be the largest issue with wireless power, which is safety. A small Tesla coil typically operates between 500,000 volts to 1,000,000 volts, and current is between 1,000 amps and 5,000 amps. He was able to achieve a bolt of electricity over 100 feet long and over 5 million volts. Tesla always thought that wireless power would be important, but didn't quite know how to implement that into everyday life during his time. Wireless power has had many implementations that can be applied to everyday life. In everyday life, wireless power is important because it makes powering electronics more convenient and potentially very efficient. With a well-designed, safe, and efficient wireless power system, you could power all the electronics devices even in your home. This has already started to take place in modern cell phones because of the short power transmission distance, being that you put your cell phone on a small pad and you can get it to charge. It also has implementations in places such as the medical industry. Rather than having a cable connecting medical devices to power and getting in the way or relying that a charge on a device will not die, you can have a wireless power in the tray that the device is on to ensure that its charging when not in use. Making the wireless power renewable is also an important piece of the puzzle. Renewable energy is the next big industry revolution and societal revolution. With the environment under threat and the amount of carbon dioxide in the atmosphere on the rise, renewable energy is incredibly important to combat this. Solar panels are an ideal solution for this issue. Solar panels use photovoltaic cells to capture energy from the sun, thus not using any type of fossil fuels to produce power, whatever they are connected to. Even though solar does not produce as much power as fossil fuels, it is perfect for powering small devices and electronics like cell phones, chargers, and small light fixtures. Our approach to design is quite simple. We're going to break this into several different parts and tasks. First, we'll be understanding how the solar panels work. Second, we will break it into designing our high step-up DC to DC converter. Third, we will design the Class E amplifier section of the project. Lastly, we'll be looking at the power transfer from the Class E amplifier to the receiver. We are choosing this approach because it is a logical way to break up the project, and we will take this step by step, and it will really allow us to understand everything along the way. Levi, if you want to.
So how will we achieve these project objectives? The first step in this process is to create a high step up output DC to DC converter. So why did we choose this DC to DC converter? The main reasons are because there's a high step up ratio and high efficiency involved. So we need a high step up ratio because the input from the solar panel is so low, only at 12 volts. The goal of this converter is to get it up to 60 volts, so we do need a decent amount of a step up. And also high efficiency. This is a very low power system being from a solar panel, and having a high efficiency step up converter will help in our power loss as well. This is the reason why it does work great with solar panels. The next step will actually be to do the Class E amplifier. So why did we choose the Class E amplifier? This was because it can amplify even more. We're going to get from that 60 volts to that desired 110 volts. It'll convert it to AC along the way, then we can send that across to the receiver to actually power the device. And it's also very efficient, so we can actually get very close to 100% efficiency, like Brad mentioned earlier. And this is good because we have a very low power system again, and this will help increase our efficiency. So to model all of this, we actually chose to do things in a certain order. So first we decided to come up with a design for our project. You'll actually see that on the next page. It's just basically taking that step-up converter, that Class E amplifier, and then our transmitter, and putting all those together into one circuit. After that, we designed the actual and figured out the actual component values that would go into that circuit, as shown above. We did this just through Excel and MATLAB, using some formulas to calculate all those values. Once those values were calculated, we then plugged those into Multisim to get our simulation. So here's the circuit that we actually simulated. As you can see from the beginning on the left side, we have our step-up converter right about in the middle of the screen. We have our Class E amplifier, and towards the right is actually our transmission over to the device. So after simulating those results, we actually got our output graphs as shown there. So our proposed outcome was 110 volts at 28 watts. And then you can actually see from our outcome, we actually hit those marks exactly on the head. This is due to our calculations that we came up with in finding those exact component values that we were looking for. We're very happy with these results, as they were exactly what we were hoping to get. So this is our Gantt chart for this project. As you can see, we're right on time with all of our tasks. This is due to some really good planning from the beginning. We took our time to do the research for our project from the very beginning so that we could get a very solid understanding of what we were getting ourselves into and how to design each component in each phase for the project. Once we were able to understand the entire project, it was pretty easy to put it all together, just taking our time and doing it step by step. So for our next steps and lessons learned, there aren't too many next steps because we actually did reach our desired outcome. But for our lessons learned, we learned that simplicity is very important. This design, as you could see, was just a couple steps, and it was very easy to implement each step in an orderly fashion to get our desired outcome. Next lesson that we learned was to use credible resources. Being able to find academically sound sites and sources were very beneficial to us because we learned about our project as well as the implementations of the project that we can use in the future. We also learned that this is an extremely marketable idea. Having renewable energy and also wireless energy in one product is a very successful combination to make a great device. For in our conclusion, the problem that we ended up coming up with in the very beginning was that there needs to be a way to have renewable energy transferred wirelessly. This problem was then solved with the approach that we took. The design approach that we took, it was very simple, and that's the reason that we actually had great success. By keeping the design simple, we were able to make a great product, and able to reach our goals in the end. These were some of the references that we used in our project, and just like to thank you for a great semester. Really enjoyed it, and we hope you have a great rest of your time.